Hi, I'm Caden Lazarowitz.
And I'm Miles Penisevsky, and this is the addition of vectors through components. So what are vectors? Vectors are values that have both a direction and a magnitude. Vectors are represented as line segments. Each line segment has a tip, which is represented with an arrowhead, and a tail, which is represented as the back of the line segment.
So when you separate a vector, usually you're going to be doing it in a two-dimensional plane. In this case, you can separate it into two component vectors, a horizontal vector and a vertical vector. The horizontal and vertical make a right angle, so conventional trig properties can be used, with the base vector being the hypotenuse of a right triangle made up by the components and the base vector.
To find the values of the component vectors, the magnitude and direction of the initial base vector must be known. In a right triangle, sine theta equals opposite over hypotenuse. Rearranging this equation, you can have hypotenuse times sine theta equals opposite. The same applies for cosine, where you get hypotenuse times cosine theta equals adjacent. Since the two components make a right triangle, these properties can be applied to solve for the horizontal value with cosine and the vertical value with sine.
So here's an example of a problem where you need to solve for the components of a base vector. The vector magnitude is 42, and the vector direction will be 222-degree standard trig. Using the previously mentioned simplified versions of the equations, we'll be doing magnitude times the trig function of theta. So for horizontal, we'll be doing the magnitude 42 times the cosine of theta, which will be 222. This will give you negative 28.1 for your horizontal component, and then we'll do the same with our vertical component using sine, and it'll give us negative 31.21.
Using the components. After you've separated each pair of horizontal and vertical components, you must add or subtract, whichever you're looking for, the like terms to find the new horizontal and vertical values. You must also use the new component vectors to find the angle of the resultant vector.
So here's how to use the final component vectors. After you've added and subtracted your horizontal and vertical vectors, you'll be using tangent inverse and the Pythagorean theorem to find the direction and magnitude of your final vector. Because again, the horizontal and vertical vectors make a right triangle, and the hypotenuse will be the final vector. So for direction, we'll be using tangent inverse of the vertical vector divided by the horizontal vector. And for the magnitude, we'll be doing the square root of the vertical vector squared plus the horizontal vector squared. So when you're given angles in vectors, sometimes it's not going to be standard trig because planes and boats will be using bearing notation. So you'll need to know how to convert them to standard trig so it can work with your calculator. To convert an angle from bearing notation to standard trig notation, you must subtract the bearing angle from 90 degrees and you'll be given a standard trig angle.
So here's our example. This is where we compile everything that we've previously learned and apply it. A plane is flying at 100 meters per second at a bearing of 70 degrees. A wind affects the plane with a speed of 60 meters per second at a bearing of 55 degrees. Find the plane's velocity in respect to the ground. So the first thing you want to do is calculate the standard trig of both of the angles. You do this by taking the bearing values of 70 and 55 and subtracting them from 90, giving you 20 and 35 degrees respectively. Now you're going to want to break them off into the horizontal and vertical components. So for the horizontal components, you will have 100 cosine 20 plus 60 cosine 35, and that will give you 143.11 meters per second for your horizontal value. You'll want to do the same for the vertical values, but using sine instead of cosine. So you get 100 sine 20 plus 60 sine 35, which gives you 68.62 meters per second. To find the magnitude, you want to use the Pythagorean theorem, so you square root the horizontal squared plus the vertical squared values, which are 143.11 and 68.62, which gives you a value of 158.72 meters per second. To find the direction, you want to take the tangent inverse of the vertical over the horizontal values, which are 68.62 over 143.11, which gives you 25.61 degrees. So your total resultant vector is 158.72 meters per second at 25.61 degrees standard trig.
So the materials and technology used for this presentation were Google Slides to create the slideshow itself, OBS Studio to record the video and our voices for this presentation, and Desmos was used to make the graphs used in this presentation.
Thanks for watching.